Hello, in today's lesson we're going to look at what happens when secants and tangents intersect inside, outside, or on a circle to create different angles. Remember that a tangent is a line or a line segment that intersects a circle at exactly and only one point. A secant is a line or line segment that intersects a circle at 2 points. A chord and a diameter are types of secants because they start and stop on the actual circle. But a secant can also be a line that just passes through two different parts of the circle. Today we're looking at what happens when angles get created in and around circles. The angles that we're going to look at today are not central angles, nor are they inscribed angles. They're just kind of in random places located around a circle. The first angle we're going to look at is an angle that gets created when two secants intersect inside of a circle. So notice in the table on your notes, in the first box, where these two secants, A, B, and C, D, intersect, we've created 4 angles, but these are definitely not central angles. Number 1, they don't look like it, but number 2, there is no point to show the center of the circle, which is probably located over here, and that point is our indicator that something is actually a central angle. So here we do not have central angles. When two secants intersect inside of a circle, in order to find the measure of an angle created by them, let's say angle 1 in this picture, we're going to look at the two arcs opposite the angle. Inside of a circle, we average the measures of those two arcs, meaning we add their measures, divide by 2. So here we can see angle 1 has a measure equal to arc AC plus arc BD divided by 2. If two secants or secant and a tangent intersect outside of a circle to form an angle on the outside, like the second picture, here we have DA, which is a secant, and ray AC, which is a tangent. They form angle CAB or CAD outside of the circle. When the angle gets formed on the outside of the circle, we look at the two intercepted arcs, and there will always be two intercepted arcs in this scenario. There's a smaller arc here, so in this picture, that's arc BC, and a bigger arc, also inside of our angle, still intercepted. In this case, that's arc DC. When the angle gets formed outside of the circle in this scenario, we always take the bigger arc minus the smaller arc, divide by 2. So in this picture, arc DC minus arc BC divided by 2 gives us the measure of angle A. And then the last scenario is if a tangent and a secant, or two tangents or two secants, intersect on a circle. So in this last picture, angle DBC is formed by the intersection of a tangent and a secant. The angle lies on the circle, but make a mental note, this is not an inscribed angle because its sides are not chords. It does, however, have a measure that's found the same way as finding the measure of an inscribed angle. To find the measure of angle DBC, we look at its intercepted arc. We look at this big arc inside of the angle, and we cut this arc's measure in half. So angle CBD is equal to half the measure of arc BEC. Again, it's not actually considered inscribed because it doesn't have sides that are chords, but it does still work the same way. As we go through the lesson today and as you do the homework, pay attention to these 3 formulas. Every problem will break down into an intersection either inside, outside, or on a circle. So the first question today, number 1, asks us to find the measure of angle 1. In this picture, angle 1 is formed by two secants that intersect inside of a circle. So our formula says to find the measure of angle 1, look at the arcs opposite angle 1. Add their measures, divide by 2. However, we don't have the measures of those two arcs. So in this question, I'm going to start by finding the angle adjacent to angle 1. I'm going to find its linear pair first. Once I find that angle, then I can get angle 1. So if I want this angle I just labeled as x, its opposite arcs are this 46-degree arc and the 38-degree arc. So to find x, I'm going to add 38 and 46, divide by 2. 38 and 46 is 84, divided by 2 means that x is 42 degrees. Now that I know x is 42 degrees, x and angle 1 are a linear pair. So to get the measure of angle 1, I can take 180 and subtract 42. And I'm left with angle 1, which is 138 degrees. Oh, there. Question number 2. I have a secant and a tangent that intersect on the circle to form angle 2. For this case, the measure of angle 2 is half the measure of its intercepted arc, the arc that's formed inside of the angle. So here I need to know the measure of this arc first. The circle is made up of only 2 arcs, the one that we need that I've highlighted, and then the rest of the circle, which is 100 degrees. So to find the measure of the arc I need, I'm going to take the full circle, 360, subtract off the 100 degrees, and I find that this arc is 260 degrees. Then angle 2 is half the measure of that arc. So 260 divided by 2 means that angle 2 should be 130 degrees. In question number 3, we have angle 10, which is formed by a tangent and a secant. Again, they intersect on the circle. So to find the measure of angle 10, I take half the measure of its intercepted arc, this space here. We don't have the measure of that arc, so just like we did in question number 2, I'm going to start by taking the full circle, 360 degrees, subtract off the 2 arcs that are labeled, 100 and 160. That leaves me with 100 degrees for this arc. And then angle 10 is half of its intercepted arc. So half of 100 means that angle 10 is 50 degrees. Okay, when you flip over to the back of the notes, question number 4. So now we're going to switch to more algebraic questions based upon these different formulas. In question number 4, I have 2 secants that intersect outside of the circle to form this angle that's x degrees. So when the 2 lines intersect outside of the circle, I have to take the measure of the bigger arc, so the larger intercepted arc, minus the smaller intercepted arc, and divide by 2. I have the big arc, but I don't have the measure of this smaller arc. However, notice that here they did give us the center of the circle. So I have a semicircle on either half. Semicircles are 180 degrees. So if I take the 180 degrees on the left half of the circle, subtract off 84 and 52, I can see that the little arc is 44 degrees. Now that I have the measure of this little arc, I can solve for x. So x is the big arc, 84, minus the little arc, 44, divided by 2. So that's 40 divided by 2, or 20. Question number 5. Again, I have two lines, in this case 2 tangents, that intersect to form an angle on the outside of the circle. This question's a little bit different for a couple of reasons. The first one is I have the angle measure. I'm asked to find one of the arcs. So when the two lines intersect outside of the circle, the measure of the angle is equal to the bigger arc minus the small arc divided by 2. And in this case, I'm going to write it out this way because our information is slightly different. So if I use this formula to build an equation, I have the measure of the angle formed, that's 55 degrees, equals the measure of the bigger arc is labeled x degrees. So our big arc is x minus, now the issue here is that we don't have anything for the measure of the smaller arc. But notice together the big arc and the small arc form an entire circle. So the smaller arc, this section of the circle, is what's left once we take away the big arc. The smaller arc here has a measure 360 minus x. When I plug that into my formula, I have x minus the small arc, 360 minus x, has to go into parentheses. Be careful of that. And now we can solve. So I would multiply both sides of the equation by 2. So 110 equals, I'm also going to distribute this minus sign. So x minus 360 plus x. When I combine like terms, 110 equals 2x minus 360. So 2x will equal 470, which makes x 235. Question number 6. Here we have a tangent and a secant that intersect outside of the circle. So I'm going to use that same formula. The measure of the angle created is equal to the big arc minus the small arc divided by 2. If I take the information from this question, the angle's measure is represented as x plus 2.5 equals the bigger arc. So here the big arc is 4x plus 5 minus the smaller intercepted arc labeled 50 degrees divided by 2. Again, multiply both sides of the equation by 2. So this will become 2x plus 5 equals 4x. I'm also going to combine like terms, so minus 45. And then we can solve for x. So 2x should equal 50, which makes x 25. In question number 7, we have a pentagon inscribed inside of a circle. We're looking for the measure of an angle formed by 2 secants inside of this circle. So if I want to find the measure of angle x, I need to know the measure of its intercepted arcs. Opposite angle x, The arcs are towards the top, this one, and then at the bottom, this arc here. I'm following the sides of the angle to find its opposite arcs. I don't have the measure of any of those arcs, but I can figure them out. Notice it's a regular pentagon. So if I split this circle into 5 congruent arcs, 360 divided by 5 means that each one of these little arcs is 72 degrees. So at the bottom, this is 72, 72, 72. But the arc that we need at the top is made up of 2 of these little arcs, which together form 144 degrees. Once I figure that out, I can solve for x. So an angle created inside of the circle by 2 secants equals the 2 opposite arcs added together divided by 2. 72 and 144 is 216 divided by 2 makes x 108. And for our last question, question number 8, there are several different ways to do this question. Here we have a picture where 2 secants intersect to form angles inside of the circle. But the angle that we have labeled and the arcs that we have labeled aren't the matching set. If I take a look at these 2 arcs, they have the corresponding angle in the middle here, but this angle, either this one or this one, same thing. If I want something to represent the measure of this angle, I can consider the fact that it creates a linear pair with the angle that's marked 14x. So let's represent this angle as 180 minus 14x. Since they form a linear pair, I'm going to represent the other angle as 180 minus 14x. Then inside of the circle, the measure of the angle formed is the sum of the 2 opposite arcs divided by 2. So if I fill into this formula, the angle that we have labeled is 180 minus 14x equals the 2 opposite arcs, 2x plus 15 and 4x plus 5 divided by 2. Once we set up our equation, we can multiply both sides by 2. So 360 minus 28x equals 6x plus 20. Just combine like terms in the numerator. Then we should get 340 equals 34x. And when you divide both sides by 34, x equals 10. Okay, please make sure that you complete the homework for section 10.6. Show your work. If you have any questions, please post them in Teams